Hi, friends. Welcome back. This is John, and this is the Regenerative Agriculture Podcast. I'm here today having a conversation with Rick Clark in celebration of the legacy of Dr. Christine Jones' work. I was privileged earlier this week to spend an incredible day and a half with Christine and several other colleagues at Rick's farm. And oh my goodness, there's seldom been a day that I can remember where I learned as much in a short amount of a time as I did in that conversation. So, Rick, thanks for being here. This is going to be a great discussion.
Oh, John, thank you. It's always an honor and a pleasure to be with you, and I reciprocate the exact emotions that you just gave. Not only, you were around Christine and I got to be around you and Christine and those other people, and it was just absolutely incredible. It was an event that probably will never be matched again at our farm. So I can't thank you enough for being part of that.
We had a lot of fun. This event was not widely publicized. Well, it wasn't open to the public. It was just specifically open to a small group. Dr. James White was there. And then, of course, Christine was there. Keith and Brian Burns from Green Cover Seed were there, along with about a dozen or maybe a few more than a dozen others. And, it's important for us to have conversations that are at an introductory level that can connect with people who are early on their journey. But in this particular group discussion, we bypassed all of that and we went to the topics that we went past all of the foundational stuff. But Rick, what was interesting for me was just, I've listened to Christine Jones' work. I'm very familiar with Dr. White's work, but it always amazes me when you start having conversations with people, how much comes out that has never been written down, that has never been recorded, how much information is there that has never really been shared with anyone else yet. It just comes up in conversation, and the day was filled with golden nuggets, one after the next, after the next, after the next.
Oh yeah. I'll tell you the one that really stuck in my mind. There's several, like you said, but when Dr. Jones was talking about if you have two plants that are within proximity of each other, and they are from different species groups, and one has a characteristic of microbes that the other one doesn't have. They have the ability to share those microbes back and forth. That was just too much for me to almost comprehend. And that really stuck with me. And then when you think about what she's saying there, it makes total sense that diversity is key. And diversity is key for so many reasons that we don't even understand yet. And that's why I could see that in our fields, and we can go anywhere you want on this conversation, but I could plainly see from being in our fields that I thought I was doing fairly well with diversity, and I've got so much more to do.
Well, building on the point that you just mentioned, and we also can bring up James White and Walter Goldstein's work on transferring microbes from one plant to another. The key piece is that these various plants can share organisms with each other, but that sharing is accelerated in stressed conditions, in stressed environments. That when you have optimal environments, then there isn't really any need to share, and they stay somewhat more self-contained, that there is less sharing going on when there isn't the need for that.
Yeah, you're exactly right. When that stress event triggers a reaction from one or more of those species, they all can partake and share. That's just unbelievable to me. But it makes sense when you really stop and think about it. But it was great to have those folks on our farm and actually out in the field, because I want people to see what we're trying to do here. I mean, John, what we're trying to do is extremely difficult. No-till, organic. I'm not thoroughly convinced that I need to maintain this purest trajectory that I'm on. I think we need to figure out how to incorporate tillage at the right times, the correct times. And all that came to light when this group was together, because Christine was very, very clear about that. But he said, if you are going to perform a tillage event, you have to immediately follow up with the cover crop of multiple species.
Yeah, let's talk about this, because this this was another one of the golden gems of the day, and that was Christine's perspective on tillage versus herbicides. And this is this recurring conversation that people are like, which is the lesser of the two evils, and how do we pick between the two? And the evils that are associated with tillage are the destruction of soil aggregation and the destruction of the soil microbiome. And on those two topics, she had a very interesting perspective. And again, this is environment and context dependent. I'm sure there are regions and areas where we have certain soil structures and wind erosion, water erosion susceptibility that we have to be very careful with. But she was very clear that herbicides cause greater loss of soil aggregation and soil structure than tillage does in most situations. There was like no question, no reservations. That was very clear in her mind that tillage was preferable to using herbicides. But then when talking about tillage, one of the questions that came up in conversation was, and this is a recurring question that I get asked all the time, is what happens with mycorrhizal fungi? Don't you disturb and destruct your soil mycorrhizal fungal population when you do a tillage event? And her reaction to that was quite interesting. Her response was, if you only till the top 6 inches of soil, there is a reserve of the soil microbial population of mycorrhiza below that. But in addition, you fracture up all of this fungal hyphae in the top 6 inches, and those hyphal strands that remain actually colonize the next generation of seeds faster than spores do, and that you do not lose any of your soil mycorrhizal fungal population as long as you immediately replant. She just rehammered that when you till, you have to immediately replant and get seeds and roots going back into that environment.
And the other thing too, that John, that I remember from that conversation was, and she even we had a whiteboard up there and she was drawing a few things, and she described that where this plant was and its surrounding area is its own microbial biome, that if you pull that plant out and put another plant in its place, some of that most of that microbial biome will stay in place and reassociate with the plant that you just put back in the ground. This, to me, I've not thought about it like this. Have you thought about it like this?
And the next piece that she said, Rick, that really caught my attention was that effect will last over winter.
Yeah.
Did you catch that?
Yes.
This effect will last over winter. So we've had this perspective that if we want to have overwintering cover crops and a healthy microbiome the following spring to plant seeds into the spring, then we need overwintering cover crops. But what she was pointing out is that you can plant cover crops that winter kill, and the microbiome that is associated with those plants when they die is still present in the soil, and that it will slowly degrade over time. In the summer months, I'm sure if you have other growing plants, then it will degrade more rapidly when you have abundant moisture. When I say degrade, the microbiome will shift to a different population. Right. But in the springtime, when the soil is cold over winter and you plant the following spring, you still have the microbiome present from that cover crop that winter killed. And this is remarkable because all of a sudden it means you can actually include more diversity and more species diversity, more microbiome diversity to as a support for the seeds that you're planting in the spring than you might have otherwise considered.
Right. So let me lay this on you, John. I've been thinking a lot about this, like I know you have. So let's talk about this transfer of microbial communities into this situation we're talking about. So what would happen, John, if we would go out and let's just take 10 acres out of the farm. That's all we got to do. Maybe not even 10. And let's put in the most diverse cover crop package that we can, comprising of the most groups that we can get involved. And then let's harvest that and let's figure out a way to grind that material up, release those microbes, and then go back out across the farm and reintroduce that group of microbes across the farm in either a liquid method or a dry method. Maybe you sprinkle it onto your seed or whatever. What do you think about that?
You're striking quite close to home here, Rick, because the answer is in concept, absolutely, I completely agree with it. There is this little secret that there are hundreds, it's probably safe to say at this point, there are now thousands of inoculants that people can buy on the marketplace. Some of them are very effective, but there's this little thing going on that you have, I've heard numbers of as high as 95% of soil microorganisms they cannot be propagated in the lab. They can only be propagated in the presence of living roots. Just like mycorrhizal fungi can only be propagated in the presence of living roots. And so we have our Biocode Gold product is a lot of those organisms are cultured in the presence of living roots. And we have a research project that is soon to be underway of developing Biocode Gold 2.0, which is going to do exactly what you are describing, of having this diverse group, diverse plant species, the diversity of microorganisms that are being propagated in association with these living plant roots. So the answer is yes. And Rick, I don't think you need 10 acres. I mean, the reality is you're better off probably doing a small plot. That is, you're better off doing a 100-foot square or even 100 square feet and just optimizing and maximizing what's going on right in that environment.
Yeah, I totally agree. And make sure you sign me up for 2.0, because I'm going to tell you right now, Biocode Gold is for real. And Christine also talked about something else that was interesting. Remember when she was talking about legumes and how they really aren't, I don't know if natural is the right word I want to use here, but they probably should not be in place as much as we use them. And she said, I didn't think about this either. She said, you have to inoculate most legumes to be able to survive in your soil environment. That tells you that should not be in that particular place.
The idea of this isn't new, but again, she just brought so much strength and emphasis to this conversation. In a podcast interview some time ago, I interviewed Helen Atau, who was an orchardist and vegetable grower, and she described how she used to have this perspective that she needs to grow leguminous cover crops, that she needs to constantly providing nitrogen, adding nitrogen to her soil. Yeah. And she soon came to realize that actually what she needed was more carbon, not more nitrogen. And she's completely organic, not adding any fertilizers of any type. And this is the point that Christine was just emphasizing, is that all of these plant species, grasses, corn, sorghum sudan grass, it's just all perennial grasses, the forbs, the list goes on. Practically every plant species, as I understood her to frame the discussion, is associated with microorganisms that have the ability to fix nitrogen and supply nitrogen to that crop in abundance, all that it requires. And this characteristic can be amplified when you're growing diverse species and you have because if they become slightly nitrogen stressed, that they can share and exchange microorganisms between species. And the point that she made, Rick, that you're referring to, that and the way that she said from her perspective, legumes are actually a very weak plant, and they're very harmful to the recovery of ecosystems and the recovery of soil structure. And we see this with soybeans, and we see it with alfalfa, and we see it with other crops, that they actually cause the destruction of soil aggregation because those associated rhizobium fix nitrogen and they release nitrogen into the soil profile in abundance, and they have a detrimental effect, and they shut down these other organisms that have the ability to fix nitrogen, just as adding nitrogen fertilizer would. So yeah, that was very stark reminder of the power of the soil microbiome that most of us don't get to see. Like, how many of us have actually observed a grass crop or a forbs crop that has abundant levels of nitrogen with no added nitrogen, no added manure, compost, or any nitrogen, or legume cover crops? I've seen it several times, but I'd love to see it hundreds of times.
Yeah, and John, we saw it firsthand, because I'll tell you, I was shocked when we went out into the field. That first field we went to was a very nice, beautiful stand of hairy vetch. I mean, this was probably waist high hairy vetch when we pulled into the field to plant no-till the corn into this. And Just in that short amount of time, I'm talking maybe from the time of planning to when this event happened, maybe 18 days, 19, 20 days. And that soil had compacted down on itself. And I had not seen that through any time until that event of when we were there. I was shocked, quite honestly, because a week prior to that, the spade went in and it was beautiful aggregation. In that short amount of time of releasing that big burst of nitrogen, it changed that soil profile in that top 1 to 2 inches. It was unbelievable.
There was practically no aggregation to speak of. The aggregation had completely collapsed.
Yep. And that was in a short amount of time. So I learned so much invaluable information from that day and a half from her. It was unbelievable. And she's just so nonchalant about how she's giving the delivery, because she's not pulling punches. And she even looked up at me and she said, Rick, I'm not going to offend you here. I'm just going to give it to you the way I see it. And I said, that's why you're here, Christine. Give it to us. Yeah. And that will make me a better farmer by listening and doing what she was suggesting we do.
Yeah, there was so much information there. I want us to dig a bit deeper into her discussion of the various plant groups for the purposes of exchanging microbial communities. But before we go there, let's go back a bit to talk about the experiments that James White and Walter Goldstein were talking about in transferring of microbes. What did that conversation bring out for you?
It was over my head, for one thing. That conversation there, I did not realize that if you were to take a seed, let's just pick a soybean seed. I don't think it matters what seed it is. And obviously we know there's a microbial community around that skin of that seed. But John, I did not realize that if you open that seed up, there's 9 billion living organisms inside that seed. But John, that what was described, what was inside the seed, and the amount of living organisms inside there just blew my mind. It just blew me away.
9 billion organisms inside every seed. And we're talking about these endophytes, and these endophytes we now understand they're not just bacteria. There are bacterial endophytes, there are fungal endophytes. There's this entire microbiome that is carried with the seed from one generation to the next. So the context, this conversation that happened between Walter and James White, I've mentioned Walter Goldstein's name here on my podcast before, and the work that he is doing in propagating and developing corn, breeding corn that has the ability to fix its own nitrogen in abundance. And he's been selecting these varieties in very challenged conditions, very intentionally, very deliberately, making sure that there isn't abundant nitrogen in the soil profile. And so he has developed these corn varieties that have this associated microbiome that has the ability to fix all the nitrogen that the plant requires. And Dr. White and Walter were describing this experimentation where they were trying to determine how can they go about transferring this microbiome from one seed line to another, from one variety to another, or perhaps to modern genetics, which I think would be an interest. I'm looking forward to having a conversation with Walter to explore how that is developing. And what they described is that they would, in the laboratory, they would sterilize one seed, that they would have to treat it. I'm not sure were they treating it with antibiotics or how they were treating it, but they would have to sterilize one seed as much as possible, which then induced stress in that seed, of course. And when they sterilized that seed, they would then germinate that seed in a solution that was comprised of the sap of the plant which did have the microbiome in it. So they would extract sap, particularly from the meristem, and germinate this seed. And this seed that had now been sterilized would soak up all of those microorganisms, and you could transfer the organisms from one to the next. But the key piece is that in order for that transfer to happen effectively, they had to sterilize that seed first to the best of their ability. And then I think it was in the context of this conversation where Christine made the comment that you can facilitate a similar transfer of organisms in the field through stress when these plants are really stressed. In other words, what I got from that is, let's say if you were to grow two varieties of corn in the same row or in close proximity to each other, and the one variety did not have a nitrogen fixing microbiome and the associated endophytes, that if you put on zero nitrogen fertilizer and you quote unquote stressed that plant that didn't have the ability to fix nitrogen, it would pick up those microbes from the associated plants or from the plants in close proximity. Isn't that amazing?
That's absolutely incredible. And that conversation really made me feel good about the journey that I'm on here with epigenetics and trying to, I'm not sterilizing like they're talking about in the lab, but we are trying to get a seed that is adapting to our system in our context. And that right there just totally reassured me that is the correct thing to be doing. And we got to do that legally, of course, but that's where I'm going to spend the bulk of the rest of my time here, John, farming. I've probably got, I don't know, I've got maybe 15 tries left in me before the next generation kicks me out. But I think epigenetics is for real, and I think it's the future here because I truly believe that, and I'm not saying that the breeders have done this on purpose, but a lot of the plant breeders have seeds today that have lost the association with the microbial biome, and that is exactly what Walter and James were talking about.
Well, they've simply, for one, we didn't know much of what we know today, or at least the general population in the industry didn't. There might have been certain individuals that did. And the second is seeds have been selected for use with fertilizer.
Yeah.
And Christine, the work that Christine is talking about is and Walter and Dr. White is to say that actually we can achieve the same or better results with a completely different system where we use biology instead of fertilizer. And biology can deliver everything that fertilizer can deliver in the right management system, in the right context. And I think it's just a completely different paradigm and a model that hasn't been in the mainstream. So breeders would have had to be very deliberate, like Walter has been, about selecting in very stressed environments in order to produce those outcomes.
Yeah, totally agree. And these are things that you've known for a long time. I mean, this is probably the underlying premise of why AEA was even created. I don't know that. I'm just saying that you figured out a long time ago that a biological program is probably going to be more important or way more successful than a fertility program of synthetic inputs. So total agreement. And it was all just all those thoughts were being confirmed when James talked or Walter or Christine. It was all right there, right in front of you, plain as day. It's like, John, it's like I look at this, John, and I say, how can the rest of the world not see this? It's so simple. Doesn't it make total sense?
Yeah, it makes total sense to me, and it has for a decade now. Rick, this work is so important. The message is so important. I feel a bit guilty at times for even feeling this way or for expressing it, but there are times when I feel tired. I get tired. I'm saying the same thing that I've been saying for 15 years. Am I going to have to keep saying it for another 15 years? It's like, I've given presentations on the plant health pyramid. It must have been 1,000+ times. And I get tired of talking about the plant health pyramid. I get tired of talking about this. I say I get tired, and it's kind of, I'm smiling when I say this because I'm really excited about the topic. There's so much potential. There's so much opportunity. And yet, oh my goodness, do I have to say this yet again?
Yeah, what you mean. You should have gotten this out of me 10 years ago. Why are you not still understanding the importance? I get that. Same thing with me. When I give a presentation, I sometimes worry that I'm talking over the same talking points because in my mind, I'm thinking, I've already said this. Why do I need to tell the next group the same thing?
Yeah, well.
But then when I change up my presentation, they'll say, well, why did you talk about that? Okay. I guess we'll go back,
Yeah. So let's dive into plant groups. So we've touched on.
This is important.
Yeah, this is important. What were the key highlights for you? What did you come away with from it?
This is what I got out. And she did not really specifically identify certain groups to be the parallel of what I'm getting ready to say. But when she was talking about weeds, and she would say, okay, what family is that weed in?
Yep.
And then she would say, okay, that's in the daisy family. So then you need to be planting these species of annual cover crops. And she would rattle those off. And then it makes, again, it's things that I never really, I thought about, but I never really went really deep thinking on. And this makes total sense. I mean, people say things like, well, Rick, I understand that you know how to grow foxtail real well, for example. Yeah, we can grow foxtail real well. Well, why don't you grow millet and sell millet then? It's things like that, finding that combination of a cash crop that fits the system that you're in. And John, I've said this to you before. I'm in Midwest America, in West Central Indiana, and I'm beginning to think that raising corn and soybeans are the wrong crops to be raising. And we can be raising better, different crops that fit the environment that we're in.
And the reality is that as you pick those better crops, what I would expect to see happen over time is that your soil microbiome is going to evolve, and what is optimal crops for your context and for where your system is today might shift and change over the next 10 or 15 or 20 years. In fact, I would expect it to.
And it should. Yeah.
Yeah.
This is a living dynamic system, the soil we're talking about. And if it's not changing, you've got problems. I say this all the time. You go out and take a test. I don't care what kind of test you take. It doesn't matter. And if you take that same test 3 weeks later, you better have different results. Because if you don't, your system is stagnant and it's not changing.
Yep. We're familiar when we think about which species to select, and this could be for which species we select to put into our system, whether it's as a cover crop or whether it's as an actual cash crop. There's this kind of foundational principle of looking at these various species in 4 macro groups, the groups of warm season grasses, cool season grasses, warm season forbs, cool season forbs. And so this includes annuals and perennials, and this type of thinking can be used to determine how they would fit into your overall growing ecosystem, growing climate, and not compete with each other. So for example, to have a synergistic effect rather than a collaborative effect, if you're growing a corn, which is a warm season grass, then you can interseed that with cool season forbs, and they won't really compete with each other because the cool season forbs are just going to kind of stay dormant until the warm season passes by, and then they're going to take off later. So you have these various groups that have these synergistic rather than competitive effects. But then there's this second principle, which you mentioned, is that of looking at associated plant families. That in reality, when we think of diversity, we should think of diversity in terms of those 4 different principles, but also those 4 principal groups, but also in terms of plant families. And there are, I'm not sure exactly how many plant families there are that fit into our cropping system, but I'm thinking 16 plus that are commonly used, if I recall correctly. I don't even remember where I got that from. But when we're talking about diversity, we should not just be thinking about species diversity, but we should be thinking about diversity of families. To your point, we were having a conversation about your love for chicory, which everyone was razzing you about. And this is where the concept of the daisy family came up. It's like, oh, okay, chicory's in the daisy family. It's a really large family. What other plants are in the daisy family? Well, safflowers in the daisy family, sunflowers in the daisy family. I'm sure there are a number of different cover crop species that are in the daisy family. And with the idea that the other species in this family may not have the exact same microbiome as chicory does, but they are similar. They bear some similarities. And that when you bring those other crops or cover crop species into your mix and your soil profile, then the plants that you perceive as being problematic have less of a reason to exist. They have less of a reason to be present because now other plants are solving the soil problem that their reason for being, their reason for proliferating.
Right. Again, I kind of assumed that this was the deal, but Christine just assured me that this is the way you have to be. What I'm going to do, and I'm going to challenge everyone that's ever listens to this podcast, go out, search the internet, identify as many groups as we can and the species that are in those groups, and then not only that, but then go into and figure out what are your prevalent weeds in your system and classify them in a group. And then it's all going to start to make sense of what we should be planting and when we should be planting and how do we terminate those species.
Christine also led a fascinating conversation about building soil aggregation at depth.
Yeah.
What were your key takeaways from that discussion?
Well, and she kept going back to the Australians on this one. And I don't know a whole lot about Australia, but when I think about Australia, I think about a lot of stress and a lot of unfavorable conditions to grow crops in.
Many of them would wish for soil like we have.
Oh my, yes, and the amount of rainfall that we get. But what was so intriguing to me was she was down 40 inches. That was her number. She was talking about aggregation at that full 40-inch depth from top to bottom. And I could not comprehend this because the best that I've ever been able to accomplish aggregate stability was about 10 inches to 11 inches deep. I don't know how you go that deep. And I even posed the question of, are these livestock acres, your grazing acres you're talking about? And she said some are, but most are not. And these folks in Australia are achieving this aggregate depth of 40 inches, which, John, that to me then goes back to, let's go back to her arbuscular mycorrhizal fungi comments. That's why you can have the mycorrhizae down that deep because they've aggregated that deep, in my opinion.
Right.
I don't know if I've got mycorrhizae that deep because I haven't aggregated that deep. So we have to be careful here about this tillage. I mean, I'm not saying tillage is bad. I'm not saying I'm going to go out and till the whole farm tomorrow, but we have to understand that I think some of the things she was referring to were also in this 40-inch depth. So if you tilled the top 6 inches of a 40-inch deep aggregation of soil, you heal way quicker than you would if you didn't have aggregation that was only, say, 4 inches deep.
Right, exactly. Yeah, that's a good point. But I think the point that she made to you out in the field, very kindly, but also very candidly, was that the reason you don't have aggregation deeper is because of your predominance of legumes in your system.
That's right. That's exactly right.
Yep.
And that was a pretty big smack right in the middle of my forehead because I've always made the assumption that the only way we're going to raise a crop that needs nitrogen is to plant legumes and plant legumes in a big way. And that was another thing too, John. You remember when she talked about how everybody thinks they need a lot of biomass and it looks pretty on top and it's not doing anything to help the system. Again, another stark reality that I didn't think I was doing the wrong thing there. And and again, like you said, she was very, very professional, very eloquent. But it's like, folks, why are you trying to be the biomass champions when that's not necessary?
Well, I think a point that Keith Burns kept repeating and bringing up when she would make that comment is that for you, in your system, the biomass does serve a purpose. It serves the purpose of weed control. So you have a reason for needing some of that in that particular context. But the point that she kept bringing up is that visual observable biomass does not build soil aggregation at depth.
That's right.
I think she didn't say it quite in those words, but if I had to summarize what the points she was making, that's the conclusion that you come to. Yeah. And there were a couple of points that lead to this. The first was that the microbial necromass that is in the top 6 inches of your soil profile cycles rapidly all the time. And you can get organic matter levels to be higher. You can get these microbial necromass levels to be slightly higher. But the reality is that you're not really building You're not building soil with what's in the top 6 inches.
That was amazing to me. Yeah, I'm sorry to interrupt you, John. That was amazing to me.
Yeah, you're not building soil with what's in the top 6 inches. So when you have all this biomass on the surface, that's all going to be cycling in that top 6 inches. So you're cycling it, you're getting carbon dioxide bursts from it, those are all valuable things, but you don't build soil with those. And so she made another point that it was, as soon as she said it, it's like, well, yeah, duh, of course. But I never quite thought of it that way. And that was, she made the comment that if funds were not a consideration, if money was not a consideration, and your objective was to build soil as rapidly as possible, she would plant a combination of diverse annuals from different groups, as many different groups as possible, and terminate them as soon as they got to the reproductive stage, and then do the same thing again and repeat over and over. Because during the vegetative stage, you have the majority of your photosynthates going out through the roots as root exudates. And as soon as you get to the reproductive stage, that switches and they start pulling out of the soil. So her point was you get maximum carbon sequestration at depth and maximum deep aggregation during the vegetative stage. So grow annuals during the vegetative stage, and as soon as they get close to reproductive stage, you terminate them and you do the same thing over again, which is, yeah, it makes sense, but that's not how we approach cover cropping when we're thinking about in terms of producing biomass.
But you know what, John? I have in our arsenal of things that we do here on this farm, I have an event called a regen year. And a regen year is when you take an acre out of production and you do not raise a cash crop. And this is what we're going to start doing, is this exact same thing right here that you just described. Now, so did you take out of that, John, that a tillage event is okay at this point? You till that annual cover crop into the ground, and then you immediately plant another one. Is that the way you took that?
I took that is a pot, that is not necessarily a detriment or negative if you immediately plant back into it. Yep.
Yes.
And termination doesn't have to be tillage. I mean, you could terminate and replant in other ways.
Sure. Yeah. And we could possibly do that. We could roll crimp, or we could just we can bring livestock in and take it, overgraze it, whatever. We can do a lot of things there. But I guess where I in my time, John, I really thought we were putting diversity into our system, and I'm finding out that I'm not even close yet.
Right.
There's so much more diversity that we need to put in that I didn't realize. And her visit here was absolutely invaluable to me. The things that we're going to change now going forward should change the look of this farm.
You know, there were a few other points that came out that were relevant to what we just spoke about. When you speak about diversity, we were having this conversation about building aggregation at depth, and someone asked the question, what are the plant groups that would be most effective at building at depth? Would it be, since legumes are out, would it be grasses?
Yeah.
And her response to that was quite interesting. What did you come away from that with?
She said, no, grasses
Yeah.
not. And everyone in the room was like, what? Yeah, I thought, let's talk about annual ryegrass, some of the best roots that go down of all species. And she's like, no, there's better choices than that. She loves forbs. She loves the daisy family. She loves chicory. And I get it. Dandelion. How about the dandelion conversation? Most people would think that dandelions would be a detriment to your cash crop. And she was putting dandelions pretty high on the list of plant species she would have in her mix.
I found her discussion fascinating about the native prairies. And she said, the native prairies were identified as shortgrass prairies and tallgrass prairies. And so in our minds, we just associate prairies with grass.
Right.
When that's not the case. And she described this native prairie ecosystem. I forget now, was it in Oklahoma or maybe in the Flint Hills of South Dakota? But this prairie ecosystem where they studied extensively, and they were able to identify a diversity of 1,600 plant species in a native prairie.
Yeah, 1,600.
1,600. And if I understood her correctly, well, this might have been in another context. There was so much information, but for certain, the minority of species were grasses. That much was abundantly clear. But I think she also said that the minority of the ground cover was grasses. I seem to recall a number of 10 to 15%, but now I'm a bit fuzzy on exactly where that number came from. But she was quite clear that she's very much in favor of forbs, and suggesting that forbs actually will build soil aggregation at depth more so than grasses will. And when you think about their root architecture and you think about their reproductive cycles, their vegetative cycles, and how they move more sugars deep into the soil, it starts to make a lot of sense that yes, they have a different root architecture and they move. I guess this is just my kind of uninformed perception at the moment. I think that the key difference between forbs and grasses is grasses will move energy down into the soil and they will build roots. Forbs move energy down into the soil and they send it out as root exudates. So again, we look at the root biomass of annual ryegrass and it really impresses us. But what Christine is looking for is actually sending out root exudates to saprophytic fungi and mycorrhizal fungi in the soil microbial community and having them build stable soil aggregates at depth.
Totally agree. And that's why she loves chicory. And there was always a back and forth about the chicory because I can't get rid of it. And she's like, well, my gosh, there's people in Australia that can't grow it. So I understand. But when you look at the architecture of a chicory plant, that's exactly what you're describing. And it's a tremendous species to have in your rotation if you have the means to terminate it and eliminate it, because it will greatly hinder the cash crops that I've been currently planting. Again, I may be planting the wrong crops. So there might be a species out there that would love to be a companion with chicory. I haven't found it yet.
Yeah, and when you get that species or other species, plural, into your cropping system, then all of a sudden chicory's reason for its vigor and aggressiveness is likely to fade. I wouldn't expect it to disappear entirely, but the population dynamics change.
Yeah, I totally agree. Totally agree.
When you think about having soil that is aggregated to a depth of 40 inches, all of a sudden, testing soil mineral profiles, even microbial profiles, to a depth of 6 inches seems kind of silly, doesn't it?
Well, that's what she said in her talking. That was another one of her talking points. She pretty much said that testing the top 6 inches is useless. It's because it's constantly recycling. And she said, for the most part, the carbon that's in that top 6 inches is going to disappear. And she said, testing there is irrelevant. You need to be way deeper than that.
Yeah, and again, she just has a very different context of her experience in developing these soil ecosystems. It's I get her point from a perspective of the microbial necromass and cycling carbon, cycling organic matter. I mean, the reality is there's a lot of cycling that occurs in the top 6 inches, so it is useful to understand from an agronomic management perspective. But if that's all we're cycling, then yeah, we've got problems. We've got issues that we need to resolve.
And I'm thinking, and again, I cannot stress enough, John, how I feel like I'm doing the right things, or at least the way my brain can work. I mean, compaction is probably our biggest enemy, and we don't talk about compaction near enough. And I try to keep we got heavy equipment. We're trying to go across a lot of acres, and it is hard to do what Christine was talking about at scale. Now, I'm not making excuses here, and I'm not saying it's not going to happen. I'm just saying I think it's going to take longer to achieve what she's talking about with this heavier equipment at scale.
I don't know if I agree, Rick. I think what she's talking about is is simply a different system than the one that you're using, a different agronomic system. The reality is, being in your fields and looking at having the conversation with her about the effects of nitrogen coming from legumes, you have such a predominance of legumes in your system that from a soil microbial perspective and from a soil aggregation perspective, the diet that your soil microbial population is getting is not significantly different from conventional fertilizer.
That's true. That's an excellent point.
So I really think that as you evolve a different cropping system that is less legume dependent, you're going to have better aggregation, and you're like that's going to require some effort to figure out, like, okay, how do you start? What cover crops are you going to use? What's the system going to look like that has fewer legumes in it? But when you get there, I think based on, you think you have a big operation and big equipment. I'm confident it's no bigger than many of those that she works with in Australia.
Could be. Very well could be. And you're right. Probably for me personally, you were much more excited about James White and her. Because that's your area of expertise. For me, the biggest takeaway for me was the fact that we are overusing legumes. And that hit home the hardest. And we also talked about how detrimental these large flushes of nitrogen are to the system, whether it be a synthetic nitrogen, a nitrogen release from a legume, or nitrogen from manure. All of these things she talked about were extremely detrimental to the microbial biome, and we have known that.
Yeah.
But I never thought about that the cover crop that is rolled down with a roller crimper, it's going to degrade very slowly. I didn't think that would create the problem that either, let's say, green manuring would do, or a pass of UAN 28%. I didn't think it would be in that same category, but it most definitely is.
Yeah, it was a fun conversation, a rewarding day. There's one more gem that got dropped that I wanted to touch on. Were you around for the conversation around Fenigree?
No.
All right, so we were having a small group conversation off to the side at one point around Fenigree, and she's like, I don't understand farmers in North America. Everyone who is grazing livestock needs to incorporate Fenigree into their pastures because it has such remarkable health benefits for the livestock, and it really amplifies their fertility and their reproductive, has very strong reproductive benefits, and that in large enough amounts, it also produces a very slight, a very mild positive flavor to milk, that you have almost this maple syrup, it's like maple syrup has been added to milk, where you have this maple syrup sweetness in the milk. And of course, I'm familiar with Fenigree. It also has all types of digestive benefits. I think it was in the context of that conversation that she was also describing that Fenigree in the diet will amplify the rumen function, where you have no methane production. Methane production drops like 95% of the rumen because you have such good rumen function when you have Fenigree. And I bring this up only because it was just a nugget, and it's important for some of the listeners of our podcasts. And it was a point that she couldn't comprehend why not everyone across the board is including Fenigree. And a big credit for organizing this day and helping to bring it about is Keith Burns from Green Cover Seed. And Keith was like, yeah, please call us for Fenigree seed, because we, based on Christine's recommendation, we imported a lot of it and we have it available. So for all of our listeners, if you want Fenigree seed, you had better call Green Cover Seed, and you'd better do it quickly, because we have lots of listeners on both of our podcasts and the inventory is likely to disappear.
Yeah, most definitely. Most definitely. Now, John, I would like to talk about something that you were unaware of, because the next morning, Christine and I went out to the field behind our house here, and Christine wanted to bring the spade and she wanted to do some digging. This is going to blow your mind, John. We walked out, and this field behind us is a very diverse, a mixture of perennials and annuals. And The first plant we came to was a chicory plant. She said, please put your spade in the ground right here and let's dig up this chicory plant. I want to see the aggregation underneath this chicory plant. So we pull up the chicory plant. The aggregation is pretty good. She says, now this is what I'm talking about, Rick. This is what we need to be seeing here. Okay. We then moved over to a little patch of annual grass that was growing. It was probably a bluegrass or a brome of some sort. And I can tell, John, by how hard I have to push down on that spade. I've got to push pretty hard now where this grass is. And it comes up and she's like, you see, there's no aggregation here. Do you understand what I'm talking about with this grass? And I'm like, yes, I understand that. And then off to the side, there was a Canada thistle right there. And she said, let's dig up underneath that Canada thistle. And John, I'm telling you, when I put my foot on the spade, it went all the way to the top of the spade with no effort. This was the best, easy spot to put the spade in the ground, was underneath this Canada thistle. And I tipped up the spade and the soil absolutely fell into aggregates, and we held the Canada thistle up, and the aggregates were just clinging to the roots. And she said, this is what I'm talking about. This is the type of aggregation you need to have in the rest of your acres. And I'm like, Christine, it's Canada thistle. Why is this happening here? and she didn't know, because she doesn't know this plant. She says, we don't have this in Australia. I don't know this plant, but we're definitely going to research it and figure out why the Canada thistle was aggregating the soil so much better than everything else. What are your thoughts on that?
I don't know. I don't have an answer for that.
I don't either.
I know that Claus Martins has been very successful with applications of gypsum to resolve Canadian thistle. And gypsum is tends to have a temporary effect on producing very strong soil aggregation. So he's been very successful with repeat applications of gypsum to supply calcium and to improve soil aggregation, and Canadian thistle tends to fade away.
Yeah. And another thing that we talked about, John, was, and again, she's not very familiar with this species. So I tried to describe to her that when you have an infestation of this Canada thistle, they tend to grow in a circle. It's not quite a perfect circle, but it's pretty close to a perfect circle. And inside of that area where that Canada thistle patch is, there'll be nothing else growing. I mean, you can have the best cover crop all the way around the perimeter of this patch, and there'll be nothing growing inside of this area. And so then we got to talking about, well, there's got to be some kind of an allelopathic effect taking place here. We need to understand what the makeup of this Canada thistle is, and possibly there's something in this plant that would become some kind of a burn down, solution that could come out of this Canada thistle. So I'm going to take it upon myself to find some labs that can research what this thistle is comprised of, why the aggregate stability is so good underneath it, and maybe we can get some answers.
I would recommend you have a conversation with Claus Martins, because I know he has worked with others who they identified an organism. So I remember from my interview with him and from other conversations I've had with him that Canadian thistle, there is one specific, I forget if it's a specific organism or if it's a family of organisms, but they are completely dependent on association with one group or one specific organism. There were also some researchers who had identified a potential pathogen that went after Canadian thistle specifically, but they found that the pathogen had highly varying degrees of success, and in some cases was entirely unsuccessful because the ecosystem that the thistle was in was so vibrant and so supportive of it that it wasn't successful. So he certainly has connections to people who have studied a Canadian thistle in some depth, and it would be a valuable connection, I think.
Yeah, I think so. I mean, I think we could find that in a lot of plant life that we just know so little amount of. The chicory plant. I mean, the thing, it truly is an amazing plant. I mean, it is a tremendous species for animals to graze on. It is, if you feed chicory to sheep, you don't need to deworm them. It's a natural dewormer.
Yeah, same is true of sainfoin and what's the other one? Trefoil, perhaps. I think
Yeah,
those three, and there's others as well, but those three are really known, well documented anthelmintics.
right.
Coming back to thinking about anthelmintics and the discussion we had a bit about fenugreek a bit ago, I was in an orchard, must be 15 years ago now, an orchardist who I'm sure is no longer with us at this point. And scattered through this smaller permaculture orchard, it was, I don't know, it was less than 20 acres and was quite old, well established. And I noticed all of these wormwood plants scattered through the orchard, the Artemisia. And I asked him what the reason for being was for the wormwood, and his response was, well, we figured out that our trees don't get powdery mildew as long as they're within 100 feet of a wormwood plant.
Wow.
And, we think about these plants as we're aware that there are many herbs that have medicinal benefit, medicinal value when livestock consume them or when we consume them. But what if they also have a medicinal effect on the environment and the ecosystem as a result of the aromatic compounds that they release into the air and as a result of their microbiome that they release into the air, the microbiome that they're associated with in the root system? And this whole piece comes to mind because during the fenugreek conversation, Ludmila was there as well, and she made the comment that, well, when you grow fenugreek with brassicas, it eliminates the need for pesticides or for insecticides in the brassica crop. And I know this is a big deal on when they plant canola in the spring. We have major flea beetle problems right shortly after germination, and it's true for many other brassicas as well. But if you have some fenugreek in the mix, that problem disappears.
We think we know so much, and Mother Nature's already got this figured out.
Yeah, and maybe there was another point that, coming back to 1600 species, another point that Christine just kept reiterating is one of the things we have really gotten wrong is we think in terms of monocultures. Mother Nature doesn't think in terms of monocultures. And the reality is that there are people who are doing amazing things like Jason Malk and his relay cropping with wheat and soybeans. That's 2 plant species. I loved the idea and the framing of it's easy to interseed a cover crop that doesn't compete with a corn crop. If you plant a corn crop and you want to interseed it, it's easy to select plant varieties that don't effectively compete with the corn. You just go in the other quadrant of cool season forbs rather than a warm season grass, and you won't have a lot of effective competition. There's this synergistic effect rather than a competitive effect. What if we developed agricultural systems that didn't have 2 or 5 or 10 species per acre, but had dozens that didn't compete with each other?
Right. That would be nice. I think that is the future. We are trying to commingle some things here. There's obviously more work we can do with that, but I see it, John. I see the monoculture crop of a corn plant growing. I look on the other side of the road and I see a mixture of 2 or 3 species going together, and there's no comparison. There's just none. So I totally agree with that. And back to your medicinal. Maybe those same species not only give medicinal value to us, but they are healing those plants that are next to them. It gets a pest comes in and does something, and it can release a healing agent and bring that plant back to life.
Or prevent the pest in the first place. I'm sure that those effects are happening. We don't fully understand them.
Oh, we don't understand hardly anything. It was absolutely amazing to have the group that we had. And when Christine just basically went unplugged and went and just took off, that's when it really got fun.
Yeah, for all of our audience listeners, I said at the beginning of this episode that the reason for Rick and I having this conversation, that I wanted to have this conversation, was to celebrate the legacy of Christine's work.
Yeah.
Christine is retiring at the end of this month, and she is adamant that she's going to completely fade away from the public eye. And I would highly recommend, if you're not familiar with her work, you need to get online and dig. Find everything that you can from her work. Pay close attention. I'm actually, I haven't done this yet, but I hope to get it done by the time this podcast airs. I'm going to put together a blog post that is an index of as much of her work as I can find. She does have her own website that I would recommend that has a lot of the papers that she's published. But again, as is true of so many people, they are, when you have a lifetime of experience, people become walking encyclopedias, and no matter how much they've published, it's never all of it.
No,
not even close.
I'm sure we heard things in our room here the other day that other people have never heard before. There's always that one thought that comes in at a different time. It was absolutely, I'm just blown away that she wanted to come here. She wanted to talk to us. And then I was more blown away when she told me she's retiring at the end of the year, or I mean, at the end of this month. And she said, "You're not going to stop me. It's not happening. I am done. I'm retiring."
Yeah, it was literally the opportunity of a lifetime.
My heart sunk a little bit because I just realized that this lifeline of information is going to stop at the end of the month. Now, we can go back and get her past work, but all of her future thoughts, we're not going to be able to get. So,
well, the reality that is, in some ways, this is a passing of the mantle. She has given so much information. She's pointed in so much. She's given us so many insights and directions into proceed, that the reality is we will continue to learn and develop on our own when we take her information and move forward. This cannot be just an intellectual exercise. We actually have to implement, and we will learn from those experiences, and we will learn. And I'm sure that there are many young people who she has inspired, and the reality is that in the next decade and 2 decades, her work will be continued and be furthered much further than she would have been able to take it on her own. And it's our responsibility as the next generation to pick that up and to move it forward.
You're exactly correct in everything you just said. You're right. She's handing the torch off. And I didn't think about it that way, John, but you are exactly correct. And trust me, I will take everything she told me, and I am going to push this even harder and further on this farm. And we're going to try to raise corn next year with no legumes in any mix that we put out. And I have already started my research. I'm trying to research myself on how many family groups there are, what species are in those groups. And I think, John, didn't she always say you need a minimum of 4 groups? Isn't that what she said?
Yes. That's the baseline. You need a minimum of 4 groups to start seeing the compounding benefits, and more is better.
And think about that, John. You, in your recollection, you thought there were maybe 16 groups, and I'm not going to hold you to that. Nobody else is either. But let's say it is 16. That's just what, 25% of the groups is all you need to have represented?
Right.
As a minimum. As a minimum. Obviously, she would like to see every group represented, but as a minimum, we only need 25% of the known groups. And I'll tell you what I'm going to do, John. I am going to not only identify what species are in those groups, but then I'm going to start, to my best ability, I may be calling on you for help, is I'm going to try to place all of the weeds that are prevalent in our system into each of those groups as well.
Absolutely. I think that'll be the perfect framing to then begin thinking about which are the groups that you need to preferentially bring into your system, because obviously they are what your ecosystem wants to grow at its current stage of succession.
That's right. And you also made an excellent point a few moments ago when you were talking about that warm season crop, whatever that may be. Why in the world would we put a companion out there that's going to compete with it? You're right. Go to the opposite quadrant with something that doesn't care about that warm season plant. It cares about doing its own thing. And those two would live in harmony then.
There are many examples that I've been able to uncover in the historical literature of plants that don't compete with each other. We've been trained to think that plants are necessarily going to compete with each other for water and nutrients, but there are many plants that have a synergistic effect and they share with each other, and that's been well documented. So I think if we can establish some foundational principles for how to think about that and how to possibly uncover other relationships, then we should have a diversity of species that have synergistic and complementary effects rather than competing with each other. And this was one example that comes to mind is the Minokan farm. And the study that they did that's been widely popularized, where they grew 7 different plant species alone in test plots and then combined them together, and I don't recall what they were and if they were from different groups, but they combined that diversity together. And in a very drought-stressed year, the crop or the plot with 7 species stayed green and continued to grow when everything else got torched from the drought. Collaboration or what?
I mean, that is the illustration that describes that whole event of diversity and synergy. I mean, that's it right there.
Wonderful. This has been such an incredible conversation, Rick. What are there any other highlights that we've missed bringing forward?
No, I don't think so. We have to understand that we need to be humbled. We have to understand that we need guidance from other people. We can't do this by ourselves, John. It takes everybody. And I took zero offense to Christine's assessment of her soil, and I didn't think our soil was that bad. She was just being brutally in-depth and thorough in her examination, and I was absolutely honored to be part of it, and it was such an honor to have the people that we asked. John, I am the people that got invited. Not one person said no, so that just made me feel really good, and I was so glad that you were part of that also.
Yeah, it was a joy to be there. Actually, there is one thought that comes to mind as something that we missed. Christine was very clear that without any question, herbicides have a greater detrimental effect on soil aggregation than tillage. But there's one group of pesticides that has an even greater negative effect than herbicides, and that is fungicides.
Yes.
Fungicides, this development of stable soil aggregation at depth is a function largely, obviously there's many players at play here, but it is largely a function not of mycorrhizal fungi, but of saprophytic fungi. And so when you add fungicides, well, guess what happens to the soil fungal population? So you lose a lot of aggregation from fungicide applications.
Yeah. And you know what, John? I've seen this in our fields that border the neighbors, and the neighbors are out and the drift comes over. You can see the change. And then you get out further out into our fields that we don't do anything. And, we don't have, knock on wood here, and I don't believe in stuff. I shouldn't have said that, but we don't have pest problems here on our farm, John, because of the fact that we are not killing all of those beneficials that make this system work. And, cutworm, armyworm, slugs, I don't see any of that stuff on our farm anymore.
Rick, do you know what I noticed when we were out in the field with your mix, with your peas and meslin mix?
Yeah.
I noticed the bird population. There were birds singing. There was such an abundant bird population. I don't remember having been in another field in the Midwest that had such an abundant bird population as what I heard in your field.
Yeah, thank you.
And that says a lot.
Yeah, that's what we're trying to get to. That is what we're trying to get to. And you're exactly right. Thank you. And you know what, John? Over where the corn was being grown with that vetch, a monoculture, we didn't have near the birds over there that we did. Now we had bees because of the blooming vetch that was there, but nothing like we had across the road.
Yeah, that's exactly right. This has been awesome. Thank you, Rick, for joining me for this conversation.
You're welcome. Thank you, John, for having me on. I admire your work, and I value our friendship. Thank you very much.
The team at AEA and I are dedicated to bringing this show to you because we believe that knowledge and information is the foundation of successful regenerative systems. At AEA, we believe that growing better quality food and making more money from your crops is possible. And since 2006, we've worked with leading professional growers to help them do just that. At AEA, we don't guess, we test, we analyze, and we provide recommendations based on scientific data, knowledge, and experience. We've developed products that are uniquely positioned to help growers make more money with regenerative agriculture. If you are a professional grower who believes in testing instead of guessing, someone who believes in a better, more regenerative way to grow, visit advancingecoag.com and contact us to see if AEA is right for you. Thank you for listening, and we look forward to working with you.